So now that you know what an ionic bond is, let's talk about some properties you want to be familiar with in regards to ionic compounds. All right, so this is going to help you when we get to the conversation on covalent bonds to be able to distinguish ionic compounds from covalent bonds. It's also going to help you identify, if you have a list of chemicals and it asks you which one of these can conduct electricity, you'll know that, oh, I know ionic bonds can conduct electricity. Are any of these an ionic compound? So, we saw this. This is just the basic property. Ionic bonds involve transferring electrons. Understanding what that bond is helps with understanding some of the properties. All right, so we transfer electrons, which means we're always going to have something that's positive and something that's negative. All right, that creates this electrostatic charge. So the plus and the minus that attract to each other. All right, and I want you to know that this is a strong attraction. Very, very strong attraction. All right, this isn't something that is easily broken. And because of its super strong attraction, that ionic compounds are solids at room temperature. All right, these it takes very high temperatures and things like that to melt salt and things like that. All right, so super, super strong electrostatic attraction, which is the basis for just about all of the properties of ionic bonds. Another component that kind of supports this super strong attraction is that all ionic compounds form crystals. All right, so here is the one salt unit. All right, here's your use black here. Here's your chlorine, here's your sodium. All right, but if you look at this, when you have the salt that you have on your table, you've got many of these sodium chlorine atoms bonded together. All right, and they form this really awesome crystal structure. So you can also think of it as you've got these alternating plus and minus, all right, which the neighboring sodiums and chlorines and things like that attract each other as well. And that's how this crystal pattern forms, right? You have these alternating positive and negative charges. All right, so this term crystal lattice is a good term to know, and just know that it's what it is this super organized structure of alternating positive and negatives from your ionic compound. All right, so a good list of things that you want to make sure you have written down somewhere. All right, so properties of ionic compounds. So if you have a question where it's asking you which of the following would have a crystalline structure, you should know that you're looking for something that would be ionic. All right, high melting and boiling points because of that crystalline structure. All right, there's, not only do the individual sodium and chlorine attract really strongly, so do the neighboring ones, and that is what causes this high melting and boiling point. The ionic compounds can conduct electricity, right? And just knowing that they conduct electricity is good enough for you guys. But just so you know, if you try to conduct electricity through just like solid salt particles, that won't work. If you dissolve it in water, which is aqueous, or melt it, then that's when it conducts the electricity. And ionic compounds are very soluble in water. Another thing that I don't have on here that I think is a good one to write down is, let's see, we're going to add atoms present. You're always going to have a metal and at least one nonmetal. All right, so the key thing here is metal. This slide is a really good slide to take some notes on. All right, this is something you'll be responsible for being able to recognize as telling you, hey, I'm looking for an ionic compound. Or hey, I'm not looking for an ionic compound. So here is a perfect example of the type of question you might get that's going to use your knowledge of these properties. All right, so this question says, which of the following would have the lowest boiling point? So we just saw on the last slide that ionic compounds have really high boiling points. So for something to have a low boiling point, we're probably looking for something that's not ionic. So let's go through these. All right. How could let's see, just looking at these names and things like that, how could I figure out whether or not these are ionic or not? That's where that last point comes from. Ionic has a metal and a nonmetal. So let's start looking some of these up. All right, we know these names. We know potassium chloride. That kind of matches our ionic naming. Potassium is a metal. Chlorine is a nonmetal. Cool. Sodium oxide. Sodium's a metal. Oxygen's a nonmetal. Glucose. See, I know that's a sugar. I'm hoping you guys know that too. You may or may not remember its formula. And I'm going to go with, let's say we don't remember its formula. Let's move on to the next one. Calcium nitride. That's going to be calcium and nitrogen. That's a metal and a nonmetal. So A, B, and D are all ionic compounds. So those should all have really high boiling points. So by process of elimination, I'm pretty sure the right answer has to be glucose. But just to help you confirm it, the formula for glucose is C6H12O6. Carbon, hydrogen, and oxygen are all non-metals. So glucose is your right answer here. So if you need help with any of this, just let me know.